Hello and welcome to this video tutorial on how to find equations by inspection. So first I'm gonna cover an electrical system and I'm gonna do a quick review in which R is just represented in the frequency domain as just R. The inductors is gonna be L times S and the capacitor is gonna be 1 over CS. So I'm gonna start solving this circuit by writing my three loops. So this is gonna be I1, then I'm gonna have I2 right here, and then I'm gonna write right above I3 in order to avoid any confusion, since even though I3 is really going around here. So first I'm gonna start by writing the equation in I1, in which it's gonna be I1 of S, and then I'm gonna open the parentheses, and within this parentheses I'm gonna put every single component that I1 goes through, which is gonna be this resistor that I'm gonna rename R1, this other resistor R2, and this inductor L1. So it's gonna be R1 plus R2 plus L1S. And then even though the current also goes through this voltage source, that's an input, so that we're going to consider that on the right side of this equation. So now we're going to subtract I2S. And in a similar way, we're going to open our parentheses, but this time we're going to look at the components that are shared by I1 and I2, which is going to be the R2 right here and the L1 right here. So we're gonna write R2 plus L1S and close our parentheses. Now we have an additional current loop I3, and we're gonna subtract that one as well, and once again open our parentheses and see what components are being shared by I3 and I1. So it's gonna be this resistor R1, so we're just gonna put that in the parentheses and close the parentheses, since that's the only component that's being shared, and we conclude with our left part of the equation. On the right side we're gonna put all the inputs that are located within the loop, which in this case is gonna be this voltage source, and voltage sources are modeled in the frequency domain by just writing V as a function of S. And that's gonna be our first equation for the first loop. Now something I like to do is that I like to write first the current that I am studying. So now I'm gonna write I2 first, and please note that I am gonna put a plus right here. So whatever current loop you're doing is gonna be positive. So in a similar fashion, I'm gonna open the loop and see all the components that I2 goes through. So it's gonna be this resistor, which we're gonna call R3, this inductor L2, this other resistor R4, and once again L1 and R2. So I'll write those components. So it's gonna be R3 plus L2S plus R4 plus L1S, and finally plus R2, and we close our parentheses. Now we're gonna subtract I1, sorry about that, of S and open parentheses. And now we're gonna look again at what components are being shared by I2 and I1, which is gonna be R2 and L1. So we write R2 plus L1S and close our parentheses. And let's not forget about I3. So we subtract I3 and we open our parentheses and see what components are being shared by I2 and I3, which is gonna be the R3 and L2. So we write R3 plus L2S, close parentheses, and I believe that's it. And yes, that's it. Now we're gonna see what inputs we have on I2, which in this case we don't have any since there is no voltage sources or current sources within the loop. So it's just equal to 0. And now let's not forget about I3. So in a similar fashion, we're gonna start with I3 as the positive one. So I3 of S, and we open the parentheses and see what components does I3 go through, which is gonna be this capacitor C1, the inductor L2, R3, R1, and that's it. So we write 1 over C1S plus L2S plus R3 and close parentheses. Now we subtract I2 of S, and we're gonna see which components are being shared by I3 and I2, which is gonna be the R3 and L2. So R3 plus L2S, and I meant to say what components does I3 and I2 share. And finally, let's do I1 of S. So we subtract again and open parentheses, and now we're gonna look at what components are being shared by I3 and I1. So it erased, I'm so sorry, and in that case it's gonna be R1. So we write R1 right here, and now we finish with our left side of the equation, and now we gotta look at the inputs. So within the loop there's no current or voltage sources, so the equation is equal to 0. And these three are gonna be your system of equations, and then you can apply Cramer's rule or whatever the problem asks for. Now in a similar fashion, we can actually also study mass spring systems. Here we have three masses, which is mass 1, mass 2, and mass 3. I'm gonna rename quickly this as K1, this is B1, this is B2, this is gonna be K2, and finally B3. This is X1 in case you guys cannot see it, X2 and X3 right here. So the way the book does it is they do two free body diagrams and get the equations from there. However, I personally found it very confusing, so I decided to find a way to do it by inspection. So that's what I'm gonna show you right now. So in a similar way to the circuits, I'm gonna first start by writing the equation for X1 for the first mass, which is this one. So X1 of S, open parentheses, and now this time we're gonna look at every component that is connected to the first mass, which is gonna be this spring and this damper. So K1 plus B1 times S. And let's do a quick review that the springs are modeled as springs and the dampers are the damping coefficient times S, and then we finally have the mass, which is modeled as mass times S squared. And here, since I'm doing the first mass, and obviously the first mass is connected to itself, so we write plus M1S squared, close parentheses. Now we're gonna subtract X2 of S and see what components are being shared by the first mass and the second mass, which in this case is gonna be this damper. So we just write B1 of S, and we're essentially done. We are gonna also subtract X3 of S and see what components are being shared by the first mass and the third mass, and since there are no components, this is just a 0, so we can just get rid of this whole thing and set this equal to the input into the system. And since we have no inputs, we can just set this equal to 0. Since there's no inputs anywhere here, the only input we have is right here. So this is our first equation for the mass spring systems. Now we're gonna do the equation for the second mass, and as always we start with the mass we are studying. So don't forget the plus right here. So we open parentheses and see what is connected to the second mass, which is gonna be this damper, this spring, and this damper. So we do B1 of S plus B2 of S plus K2, and let's not forget that the mass is obviously connected to itself, so M2 S squared. So that concludes the part for the x2. Now we're going to subtract x1 in a similar way with the currents and see what are the components that are being shared by the first mass and the second mass, which again is this B1. So we just write B1 of S, and that's pretty much it. Now we're going to subtract x3 of S and open parentheses and see what is being shared by the second mass and the third mass, which is this spring. So we just write K2 right here, and we're done with the left side of the equation. Now we gotta look at the inputs on the right side. And since we got an impulse right here, in a similar fashion as the voltage, we just put F of S, and this is our second equation. Now finally we're gonna do the equation for the third mass. So as always we start with our third mass, so x3 of S positive, don't forget it, and we open parentheses, and we're gonna see what components are connected to the third mass, which is the third mass itself, this B3, and this spring. So it's gonna be M3S squared plus B3S plus K2, and we close parentheses. Now we're gonna subtract what is connected to the second mass and the third mass, and that's just gonna be K2S and right here, which connects this, so K2, and that's the only component. And we can also do x1, but in a similar fashion, since there is no connections whatsoever to x1, it's just a 0 right here, so this term cancels, and we're done with the left part of our equation, and we now set this equal to the inputs. However, since there are no inputs on this side either, it's just gonna be 0. And that concludes our system of equations. So these are the equations you should end up with for this mass spring system. And let me go quickly over the electrical system very quickly, and this is the system of equations that you should end up with this circuit. So that concludes the video, and thank you for your time.